Okay, this is going to be a little bit of a longer video, hopefully not too long though. So let's just knock it out. How do you find the perimeter of a composite figure? You're just adding up all the sides, just like what we've done for everything else. How do you find the area for a composite figure? This is where the puzzle begins, because first thing you need to understand is this dotted line here is not part of the composite figure. Just the solid lines are part of the composite figure. And then you have to look at your figure and say, okay, where can I break it down to utilize the formulas that I already have in order to find the area? Okay, the perimeter is the easy part unless they don't give you all of the sides. In this case, for example, 13, they do. So I'm going to knock out perimeter real quick. So P is equal to 18. I'm not going to do all this. Yeah, I guess I can. 18 centimeters plus 6 centimeters plus 3 centimeters plus 11 centimeters plus 9.5 centimeters plus 6 centimeters plus another 6 centimeters. All right. Calculate. 18 plus 6 plus 3 plus 11 plus 9.5 plus 12. 59.5. So the perimeter is 59.5 centimeters. Area. For area, I'm going to break this composite figure into two pieces. Okay. The first one, I'm just going to call it A1 for area 1. The second will be area 2. All right. So for area 1, it is a rectangle, and the area for a rectangle is just base times height. So we've got 18 centimeters times 6 centimeters. So area 1 is 18 times 6. 108 centimeters squared. All right, there's A1. I'm not writing my sentence yet because I haven't got the area for the entire composite figure. Let's find A2. A2 is just a triangle, but notice that it's just this portion. The dotted line is just to represent what the height is so that we don't have to search for it. All right, so for the triangle, the base is this piece here. All right, so what is the base? Well, it has to be the base because this is the height. You can't use this as the base and this is the height. That wouldn't work. So this piece here has to be the base, and the 9 centimeters is going to be our height. So to find the base, we know from here to here is 18 centimeters, which means from here to here is 18 centimeters as well. So 18, we subtract the 6 that we know about this one and the 3 for this one. 6 and 3 is 9. So 18 centimeters minus 9 is 9 centimeters. So the base is 9 centimeters. I'm sorry, the area for a triangle is base times height divided by 2. So there's the base. The height is the 9 centimeters. And then it's divided by 2. So this is 81 centimeters squared divided by 2. So it's 40.5 centimeters squared is the area for this A2. All right, now all we have to do for the entire composite structure is just add up the two areas. So we have, it looks like 148.5. The area is 148.5 centimeters squared. All right. That's not all. Okay, let's keep going. So the next composite figure we have, it looks like we've got another, it says, Rosie is planting a garden with the dimensions shown below. She wants to put a thin, even layer of mulch over the entire surface of the garden. So that's the area. The mulch costs $3 a square foot. How much money will she have to spend on mulch? Well, let's find out the total area because it's $3 a square foot, and we know area is measured in squares. So we need to find the area of this garden. So I'm going to create a faux line here. So I have area 1, A1 is just a rectangle, and it's base times height, so it's 8 times 4. 8 feet times 4 feet. So that's 32 feet squared. Area 2 is this whole structure down here. Please know this dotted line is not part of the structure. It's just representing what the height is for this trapezoid. And the area for a trapezoid is base 1 plus base 2 divided by 2, and then all that times the height. So base 1 is here, base 2 here, and our height is 4. So base 1 is 8 feet, just as it is up here. 8 feet. Base 2 is 14 feet. Divide those by 2 after you find the sum. You're just getting the average of them. And then you're going to multiply it by the height, which is 4 feet. All right. So 8 plus 14, 8, 9, 10, 11, 12 is 22 feet. 22 divided by 2 is 11 feet. And then we're going to multiply that by 4 feet. We're going to get 44 feet squared. So here's area 1. Here's area 2. We need to add the 2 up to find the total area for this composite figure. And it looks to be 76 feet squared. But that's not the question they asked. The question they asked was, how much money will she have to spend on mulch? So the only sentence I need to write here is I need to calculate how much she's going to spend on mulch, and that's going to be my sentence. So this is the total area. So 76 square feet. And we know it's $3 a square foot. So this is just a little unit conversion that we haven't even learned about yet. $3 per feet squared. Multiply 76 times 3. We'll get 228. So Rosie will spend, it's a dollar sign, 200. $228 on mulch. That is answering the question. Okay. Let's go to the next one. I know it's a try it, but I'm going to go ahead and do it just to make sure you have it. So find the perimeter and area of the shape shown below. Perimeter is easy. They give us all the sides. So perimeter is just 2 plus 2 is 4 feet plus 9 feet plus 7.3 feet. All right, 9, 10, 11, 12, 13. So that's 20.3. The perimeter is 20.3 feet. Yep. All right, let's find the area. The area, I'm just going to create a cute little square right here. All right, just brought this down. When I brought this down, it creates a right angle because it's a direct, it's perpendicular to the bottom line. All right. So the area for area 1, this will be area 2. Area 1 is just a rectangle or a square. So area 1 is just base times height. So 2 feet times 2 feet is equal to 4 feet squared. Boom. Let's find A2. A2 is a triangle. It's not just a plain old triangle. It's a right triangle. But we don't have to do anything exciting here but find the area because we've got the base. Oh, do we? So 9 foot's representing from here to here. That's not what we have. This is 2 foot, so this is 2 foot right here. So this piece that we're needing for the actual triangle is 9 minus 2. You see, this whole thing is 9. So we need to subtract this little 2 foot piece so we have what we need for the base of the triangle. So the base of the triangle is 7 feet. So 7 feet, base times height divided by 2. So there's the base. The height, well, this side and this side are the same. So this is 2 foot. This is truly a perfect square. So 2 foot is the height, and we got divided by 2. 7 times 2 is 14. 14 divided by 2 is 7. So this is 7 feet squared is what the area for this triangle is. So we have A1 and A2. Let's add them together to find out the total area for our composite figure. So that's 7 plus 4 is 11 feet squared is the area of this figure. All right. Oh. All right. Let's do a raspa, a 2-dimensional raspa snow cone. So it says find the perimeter to the nearest hundredth of the composite figure made up of a semicircle and a triangle. So I want to find not just the perimeter, I also want to find the area of this as well. I can't remember if I did that in class, but I want to make sure that you can find both the perimeter and the area for this critter. All right. So I'm going to bring it in a little bit closer because I'm going to be writing on it. I don't want you to miss out on some stuff. The top part, let's do the perimeter first. Perimeter is just 1 inch plus 1 inch. And then it also needs this semicircle piece up here as well. All right. So perimeter is 1 inch plus 1 inch plus, well, we need to find out what this is. This is a half of the circumference of a circle. Circumference of a circle is just 2 pi r. Or pi times d, which we have d here as well. Let's just do that. So let's do pi times d. That'd be an easy one. If diameter is 1 times pi, but wait a minute, this is only a half of 1. So this is a half of circumference. So we need to take this pi times d and divide it by 2. Okay. So the diameter is 1. So I've got pi times 1 is pi, and then divide by 2. So that's 1.57. What are they having us round to the nearest hundredth? So for this circumference, for this semicircle, it's 1.57 inches. Oh, give me just a second. And pause. Okay, let's finish this up. So the perimeter for this glasses. For this composite figure is 3.57 inches. The perimeter is 3.57 inches. This is a tiny little thing. All right, now let's go ahead and do the area. I'm going to do one more figure after this, but let's get the area for this one. And the area, well, we've got a triangle here, and we've got a semicircle. Circle, for the circle, we'll call them A1 and A2. A1 is just pi r squared, is the area for a circle, but this is a semicircle, so cut that sucker in half. All right, so what are we doing here? The radius is half the diameter. The diameter is 1, so the radius is 0.5. Take 1 divided by 2 in your calculator. So that's equal to pi times 0.5 inches squared, and all of that divided by 2. So pi, well, I can't do that. I have to do 0.5. 0.5 squared times pi equals, and then divided by 2 equals 0.39. I want to check that one more time. 0.5 squared times pi equals divided by 2. Yep, 0.39. We're rounding to the hundredths, so 0.39 is what we'll go with on that. So the area 1 is 0.39 inches squared. All right, area 2 is where it gets fun. Area 2 is a triangle, base times height divided by 2. So our base is 1 inch. Our height, we don't know yet. We're dividing by 2. So we have to find the height of this triangle that cuts right through the middle of these suckers. Okay, it's the distance from here to the point. From right here is what we're measuring. In order to find that, that just created a right triangle right here. So we can find what this leg is by just using Pythagorean. All right, the hypotenuse is 1 inch. Well, one of the legs is just half of an inch because it's only this piece here. So 0.5 inch. And then we're looking for A. Okay. So 0.5 squared is 0.25 inches squared. Double check myself here. Yep. A squared plus is equal to 1 inch squared is just 1 inch squared. Subtract 0.25 inches squared from both sides. We get A squared is equal to 0.75 inches squared. We're going to isolate and solve for a, so we have to take the square root of the square. What you do to one side, you do to the other. So we get a equals, we take that 0.75 and take the square root. And I get 0.866, so that's going to be a 0.87. Just double checking myself. Yep, 0.87 inches. Okay, so that is the height. So 1 times 0.87 is 0.87, and then divided by 2 is 0.44 inches squared. The total area for this composite figure, I'll just add these up real quick. So the area is 0.83 inches squared. Okay. One more I want to do with y'all, and that's down here. It's the try it, but it's a fun try it. Because you just have a square and you have two semicircles. Two semicircles, as long as they have the same diameter, make one circle. All right, so we're dealing with a circle here and a square. And it says find the perimeter and the area of the shapes below. Area in this case is going to be easier than the perimeter. Okay, we just need to find the area of one circle and the area of the square. So area 1, which we'll call the square, is just base times height. So 2 inch times 2 inch is equal to 4 inches squared. Okay. Area 2, which we'll call both semicircles together, which makes a full circle, is equal to pi r squared. So that's pi times the radius squared. The radius is half of the diameter. The diameter is 2. 2 divided by 2 is just 1. Okay, so it's 1 inch is the diameter. So area 2 is just 1 squared is 1. 1 times pi is just pi. So 3.14, what are we rounding to here? Hundredth. So 3.14 inches squared. Add these together, and this will give the area for the entire composite figure. So 4 plus 3.14 is 7.14 inches squared is the area. Okay, let's find the perimeter, which is going to be a little bit tougher. So if these two are 2 inches, then since it's a square, these are both 2 inches as well. Please remember the dotted lines are not part of this composite figure. They're just representations to show you the lengths of the sides / diameters. Okay, so we've got 2 inches plus 2 inches plus, well, we've got two semicircles again, which, like I said, if you put them together, it's a whole circle. So we just need to find the circumference for this full circle and add it to the 2 plus 2 inches. All right, so the circumference, and we're using 2 pi r. You could use pi d, it doesn't matter. We already know 1 inch is the radius. So that's 2 times pi times 1 inch. So that's pi times 2 is 6.3. No, we're going to the hundreds. So 6.28. So 6.28 inches is the circumference for the circle. And we're just going to add that to the 2 plus 2 plus 2 in inches. 6, 7, 8, 9, 10. So the circumference is 10.28 inches. All right, that's it for tonight. I haven't lectured over working in 3 dimensions yet, so I will record that tomorrow.